What does statistical analysis have to do with me? Statistical analysis can be far away from us, or it can be very close. If you completely believe media reports, are accustomed to listening to rumors, and do not make any judgments or decisions in life, then you can completely ignore them. The stock market, diagnosis, betting, quality control, market share, whether you like it or not, we all live in a world of probabilities, and we may need to take a gamble anytime and anywhere. In other words, everyone is a gambler, and the technology that gamblers need to learn, besides cheating, should be statistical analysis. Maybe you sign up for a machine learning or deep learning course hoping to be able to predict stocks or even the future, but you still hate statistical analysis. You think you can just collect the data, throw it into the model, and then make a cup of coffee to get the answer. Why do you need to reject the null hypothesis or find a 95% confidence interval? If McDonald's claims that its market share is 35%, and you are responsible for market research, you find that 120 of 350 randomly selected consumers choose McDonald's. Would you reject or accept this market share assumption? This question and subsequent questions assume a significance level of alpha equals 0.05. If a pharmaceutical company claims that its new COVID-19 drug has a cure rate of more than 50%, as a tester, you randomly select 30 users and find that 12 people have recovered. Are his claims valid? You are a household census enumerator. 5 years ago, 20% of households in a certain community were poor. Now you survey the same community again. A sample of 400 households was randomly selected, and it was found that 70 households were poor households. Is the ratio of poor households in this community the same as it was 5 years ago? These three questions are all about testing the population, real situation, proportion. Using a simple average, you can intuitively reject these three hypotheses. But from a statistical point of view, these three hypotheses cannot be rejected, only accepted. Sounds ridiculous, right? In fact, not at all, because don't forget, the numbers you collect are just samples, and the sample values are random variables and cannot be regarded as a fixed value. That is, the sample proportion cannot be used to judge the population proportion. To infer the population proportion from the sample proportion, that is, the real situation, statisticians use the binomial distribution to calculate the mean and standard deviation, and then use the assumption of normal distribution to determine whether the statistical value falls within or outside the critical value. Taking the example of McDonald's, the sample proportion is P equals 120 divided by 350 is equal to 0.3428, which is not equal to 0.35. We ignore the calculation process, and the final calculated statistical value z equals minus 0.274, which falls within the critical value range of plus or minus 1.96, so the hypothesis of a market share of 35% cannot be rejected. The methods for other questions are exactly the same. Statistics tell us that although there is a gap intuitively, there is no statistical difference. To solve the above problems, we have to learn the mean and standard deviation of the binomial distribution and the method of estimating the proportion of the population using the normal distribution, z-distribution. In addition to estimating the average value of the population, quality controllers often need to estimate the variation of the population in order to understand the stability of the product during the production process. At this time we will need to use chi-square distribution to calculate the result. For the quality control department of an enterprise that packages milk powder, as long as the variation number of the packaged milk powder capacity exceeds 120, the quality control department will order to stop packaging and inspect the milk powder packaging machine. Now the quality control randomly selects 30 packets of milk powder and calculates that the variation number is 132, significant level alpha equals 0.05. Should production be stopped at this time? Intuitively, of course, 132 greater than 120. However, when the degrees of freedom, df, are equal to 29, equals 30 minus 1, we calculate that the chi-square statistical value is equal to 29 times 132 divided by 120 is equal to 31.9, and looking up the table, we find that the critical value is equal to 42.56, which is greater than the statistical value of 31.9. We cannot reject the null hypothesis that the variation is equal to 120, and the machine does not need to stop. In the same way, during the production management process, a certain factory produces an O-ring. It claims that the standard deviation of the diameter should not exceed 0.007 centimeters. Now take 28 O-rings and find that the standard deviation is 0.0086 centimeters. Then, under the premise of the significance level alpha equals 0.05 next, are the factory's claims worthy of acceptance? Intuitively, there is a problem, 0.0086 greater than 0.007. This chi-square statistic is equal to 40.75. The critical value of chi-square with degrees of freedom equal to 27 equals 28 minus 1 should be 40.11, which is statistically considered to be just over. That is to say, the null hypothesis is rejected, and the factory's claims are not worthy of acceptance. Therefore, whether you are a market researcher or a quality control personnel, knowledge of statistical analysis is indispensable. An article I wrote last time on whether a positive rapid screening test confirms the diagnosis also shows that statistical knowledge is also indispensable in life. Can I learn machine learning without knowing statistics? It should still be possible, but you can learn more solidly if you have a statistical foundation. Statistics uses samples to infer the population, while machine learning actually uses the training set to predict the test set. Predicting the population, truth, is our goal. Statistics tend to use mathematical methods to do hypothesis testing, and the steps are rigorous, while the algorithms of machine learning are quite diverse, and they directly perform regression, classification, grouping, and measurement methods. There are quite a few. In fact, a lot of statistical knowledge is used in machine learning, such as Bayesian theorem, confusion matrix, maximum likelihood, correlation coefficient, etc.